now going to look at solving inequalities. It's actually quite important that you've gone back and looked at the Key Stage 3 lesson on actually solving equations, because the skills and techniques are very, very similar. Let's just first remind ourselves of the inequality signs. Here, if it's facing this way, it means less than. Remember, if I suddenly put that extra line in, it means less than or equal to. It's facing this way, it means greater than. Again, if I put the additional line in here, it means greater than or equal to. You can see the equal sign there. The equal sign there. It means it's allowed to equal it as well. So, how do we solve this inequality? Well, basically, the skills and techniques are exactly the same as solving an equation. There's a couple of things you do need to know, but I'm going to do this question just as I would if it was equal to 22. It's not, it's less than 22, but the skills are going to be exactly the same. I look at that equation, I look and see what numbers I need to remove to get x less than a number. 22, out the way already. Quite happy with that. These are the two things I need to remove. Times by 5 and the take away 3. How do I do it? Same as I do with solving an equation. I do the inverse operation, the opposite. Opposite to taking away 3 is to add 3 to both sides of this inequality. What would I end up on? Well, I've got the 22 at the moment. Take away 3, I'm adding 3 to it, so it ends up as being 25. I'm now got to get rid of this multiplied by 5. How do I get rid of times by 5? I do the opposite. I divide by 5. So I divide each side of this inequality by 5. So I'm doing 25 divided by 5. 25 divided by 5 is 5. What have I done? I've divided both sides of that inequality by 5. Just imagine now, we've solved that inequality. X has to be less than 5. And again, you can check you've got that right. Just put any number less than 5 that you can think of. Say 4. 5 times 4 is 20. 20 take away 3 is 17. 17 is definitely less than 22. And remember, there's no equal sign on that 5. So what would be the largest whole number that satisfies that inequality? The answer would be 4. Just imagine a line here. There's your 5. The inequality sign is less than, so you're moving this way. What's the first number that you come across? Whole number is 4. So if somebody wanted to know what was the largest whole number that satisfies that inequality, you could definitely say it was 4. But the solving of the inequality, the answer is x less than 5. Right, what we're going to do now is we're going to have a look at a slightly harder inequality to solve. And remember, the technique is to pretend really it's an equation and use the same sort of skills, even though there is a slight catch, and we'll come to that later on. But what is different about this inequality is I've got 7x on this side, but I've also got the variable x on the other side of the inequality. So it makes it a slightly harder equation. Slightly harder inequality to solve. But remember, when we did equations and we had x's on either side, there was a technique. The first thing we must do is to bring the x's all onto one side in order to be able to solve. Same thing applies to inequalities. No different. I look at the two expressions. I decide which side has the most x's. This side has got 7. This side has got 5. So what am I going to do? I'm going to collect all the x's on this side of this inequality. So what have I got to do? I've got to get this 5x, I've got to remove it, and I've got to bring it onto this side. I've not touched the minus 3, it's going to stay exactly where it is. I've not touched that plus 11, it's going to stay exactly where it is. How do I do the plus 5x? Well, basically I do the opposite to plus 5x, which is to take 5x off. Just imagine if I took 5x over there, it would disappear. Wouldn't be there. But I must now do it exactly here. I must take 5x off that 7x. So what am I doing to the inequality? I'm taking 5x off both sides. So 7x, take away 5x, leaves me with 2x. Not touched, take away 3, not touched that plus 11. Now I'm back to that first inequality question that I did with you. Which of these numbers is out the way already? Plus 11. How am I going to get rid of minus 3? I'm going to do the opposite. I'm going to add 3 to both sides of this inequality. So when I add 3 to that plus 11, it makes a grand total of 14. And finally, to get rid of that times by 2, I do the opposite to timesing by 2, which is to divide both sides by 2. So when I divide that 14 by 2, the answer is 7. So I've solved a fairly complex inequality. The final answer is x must be greater than 7. You can check you're right by putting a number greater than 7 to see if the left-hand side is in fact greater than the right-hand side. So if I put the number 8 in, 8 sevens, 56, take away 3 is 53, 5 times 8 is 40, plus 11 is 51, 53 is greater than 51, so I know x has to be greater than 7. If I wanted to find the smallest whole number that satisfies that inequality, just imagine an inequality line. There's your 7. What is the first whole number that you would come across? And why am I going that way? It's because it's greater than the first whole number that you would come across is 8. So 8 is in fact the smallest whole number that satisfies that inequality if it was asked for.